Hello, welcome. So, in the last episode, we built this much of a compiler. It's not much of a compiler currently. So, let's start moving it a little bit in the direction of how compilers usually work. Big thing that is missing is what I like to call tokenizer. That's probably my favorite word for it, but there's lots of other words. It's also called lexer, lexicographical analysis, a scanner. So all of those are just different terms for the same thing. Kind of comes from linguistics, I think, where lexicographical analysis is the analysis of written words, I believe. So why would we want to do that? Well, say you're parsing this. Right now, what it's doing, it's reading a number. It's switching on the next character, whether it's a minus or a plus, and then it's parsing another number. Well, say we wanted to skip any spaces in the input. Well, we'd have to skip white space here, and we'd have to skip white space here. So we'd have to increment stir first, and then we'd also have to do it here. So in a lot of ways, it makes a lot more sense to abstract this away so that we don't have to skip white space basically everywhere in the parser. So that is probably the best reason for separating the two out, so that you have something that deals with the low-level character-by-character details, and then something a little bit higher level that deals with the grammar of the language that you're trying to parse. So that's kind of the motivation behind the split, and I think most people agree that it's a good split. It does make the parsing significantly simpler. There are parsing techniques that don't require a separate tokenization phase, but I'm not going to be teaching those. They have their pros and cons, but the biggest problem in my book is that they don't handle errors very well. It can be really difficult to know exactly where the error is if you do any kind of backtracking. So I'm going to be showing recursive descent, and recursive descent is like industry standard for most languages out there. It's just a lot easier to know exactly where the errors are. And so that comes to my next point. And my next point is, what's the most important thing about a compiler? And if you say generating machine code, I'd say that's a very, very close second. I think the first most important thing about a compiler is generating good error messages. And I think the Rust compiler is a perfect example of this. They decided to focus on really good error messages, and it has made adoption of the language a lot easier considering how complex Rust is. So if error handling is the most important thing, then what's the most important thing that we need to get out of a tokenizer? Well, I would say the most important thing, the fact that this is a C file is just messing with me. Let's just go in here. The most important thing about a compiler, one, two, so then if this is the priority, then what should the tokenizer tell you first and foremost? Well, I would say the position of the token is kind of one of the most important things. And then second, which token it is. That's needed for parsing. So this would be things like so then the third thing, then the third most important thing is probably like the literal. So for identifiers, it would be the string, or for integers, it would be the int value, etc. So I would say that this is the priority that we have. So then, what should a token be? Well, if we're looking from the data-oriented direction, then we want a token to be as small as possible. So the token should be storable in the syntax tree or even in the IR. The reason I would want it to be storable is then, so for example, in the parse tree or the abstract syntax tree, we can just have a binary node, and then we can check which token it is. And based on the token, we can do the operation. So it just saves a little bit more representation. So I'm going to go out there and say that a token should be a type and a position. And we can actually just stuff that into 32 bits. And this allows us to store the token elsewhere, and it gives us the position information. And since we are loading all of the source code already, the position can actually just be a pointer, or really an index into an array of bytes, essentially. So I think this is what I'm going to go with. There are other ways that you could treat tokens. You could treat tokens like they're ephemeral and just throw them out after, in which case maybe bit packing them into 32 bits is not really that useful. But I think we get a lot out of this. So I think I'm going to go this direction and just run with it. So I think that's what we're going to do. So then I think it makes sense to, I think just to do a type def, yeah? And I think and actually I want to make the type, yes, that's basically what I want. I think it'd probably be better, because we're going to have lots of different kinds of enums going around. I think it would be better to do this. We definitely need an end of file token. Number is maybe not the best one. I'm just going to call it an int. And then for operators, we need, do we call it add or do we call it plus? I think we call it plus. Or wait, this is going to be the subtype of a binary operator, so I want to call it add actually. Yeah, I think this is what I want to do. So we've got token type. I'm just going to do the type def. And then this needs token here. And I think I can do this. I'm pretty sure. Yeah, I think this should be 32 bits. We can always assert that. Let's just assert that. There. Just to make sure that our assumptions are correct here. Assert, I kind of wish there was like a automatic way to do the proper include. I'm sure there is. I just don't know the magic incantation. It's one thing I miss from Go. Okay, so we've got a 32-bit token. We've got the token type. I wonder if I should have white space as a token. The reason why I wonder this is that if we were doing a language server, we would probably want white space and comments as separate tokens. We'd also want that for like an auto formatter. Yeah. I think I'm just going to do it. It can be removed later. But say you were wanting to make your own language. I would say you'd probably want white space and comments as separate tokens, and then just do a higher level thing where you ignore white space and comment tokens at that higher level before you go into parsing. And then that way, at some level, you can represent white space and tokens, or white space and comments, rather. 6 to 1, half a dozen to the other. Let's do it. It'll simplify the tokenizer, and we can filter them out later. Okay, so we've got the token. Now we need to actually figure out the well, I guess actually struct tokenizer. Let's call this source. I think we want the current token, and yeah, I think that's what we want. So we got the tokenizer, and then I want to take the token here. There's actually a good reason for taking the token in, and I'll get to that in just a moment here. So one thing that you'll notice about the token here is that there's no indication of length of the token. Like there's no way to determine how big the token is. But actually you can just scan until you find the next token, and then you've got the length of the token if you've always got the source code. So so then we just need to write some code to do that. So I wonder if that code could even return a token as well. I guess not, because it needs the type. Okay, so find token end is what we need, like that. So first we need to identify the token. So, well, first we need to find the end of the token, I guess. We have, case. So then this is not what we want. Return. That's basically what we want. So this will find any white space, and just to denote that this is on purpose. Here we want to fail. Oh, we don't have an invalid token, do we? We just have end of file. We need an error token of some sort. Yeah, so the invalid token will be given if there's an error, but it also gives you a place to start. So the first token will be invalid until you get going, basically. So this will end up being zeroed, and then, yeah. Okay, so we've got white space, we've got an invalid token, we've got I think in C you can now do these sorts of things. I think that's valid C. I mean, it doesn't error, which is interesting. I don't know when this was introduced, but I don't think that was a thing last time I wrote any C. So, but that seems to work. So next token just identifies what the next token is and figures out what its position is. That's all it does. And then find token end is responsible for figuring out how long the token is. So I think we just have two more things here before I get distracted. We've got adding and we've got subtracting. Okay. And then I think that's all we have so far. And then we've added the ability to parse white space. And then here we need to figure out how long the token is. So switch, I guess. I guess it's actually a dot. Yeah. It's kind of what I want, except not this. Oops. We're not going to parse comments right now. So actually, this will add later. I'll just comment it out just to remind us to do it later, but we're not going to do that right now. So we've got white space. Not loving how many characters this is. I wonder. I guess it's fine for now, sort of. Let's actually just. Maybe. I just had a thought. What if we do this? Did I? Oh, yeah. Often, if I make a typo where I use the wrong name by accident, usually that means that that's the correct name. Because I want the names to be intuitive, right? So if I intuitively guessed the wrong name, then I usually rename it because maybe I picked the wrong name initially. And we're dealing with tokens, so I think token in the name makes more sense rather than type, because we're not dealing with types yet. So then this is probably going to be static. Static just means like internal to this file, I guess you could say. It's a poor name for it, but yeah, it is what it is. I guess they just didn't want to add too many keywords, so they started reusing the static keyword to mean things that have nothing to do with the word static, I guess. I don't know. Okay, so we have that, and then while equals the token type, we plus plus if, yeah, no, that's exactly what we want to do. And then we basically just return the index. And we could get this one variable smaller. What's wrong with that? Oh. In C, you must have your declarations in the correct order. And it's not always the order I want to put things in, but I don't want to forward declare it. So let's discards qualifiers. I don't care. Can I just... Yeah, that's fine. Did I use const care up here? I guess I did. Good. Okay. Okay. I think this actually works. I think it's done. Oh, we're missing our fall throughs here. Ooh. If I spell it right. This looks correct. One thing we're not doing is storing the previous token within the tokenizer here. So, do we care? Probably. Like maybe this is not a very good name. How do we do that? Maybe we call this find next token and then Tokenizer. Oh, that's fine. Find next token. Then maybe just do a do while loop here. Basically. Yeah. So one of the nice things about this scheme is you can always find the next token if you, for some reason, wanted to, say in an error message. So you could have fancier error messages by scanning the local area for tokens. And actually, you could probably scan backwards if you really wanted to. I haven't found a use for that, but you totally could. So that allows us to get away with just having a position. Now, one other thing that would be really nice is to be able to figure out the line and column of a token given a position. I'll save that for when we're handling errors, which we will do maybe even next episode. I'm not sure. I think we need a bit of a parser first before we can handle errors. So we've got next token. So now we can actually refactor this code to use the tokenizer. And we'll get an upgrade of being able to handle whitespace at the same time. So what's the best way to do that? Let's just create, let's see here. Do we want an init function maybe? I don't think we need it. Well, oh, there's one last bug that I think we have, but I'll fix that in just a moment. There's probably a few bugs actually. One of the bugs that we're going to have is EOF here. There we go. So it'd be nice to have this in just like an init function, I think. So I think I'm actually going to put that in an init function. No, actually. Yeah, that's what I'm going to do. That was exactly right. It's nice to have AI to help you out. So we do want a tokenizer. I want an init tokenizer with RV. Okay, and then we want to no. Tokenizer. Basically, It won't have a 0 termination, though. How do we handle that? You can just call find token end, I think. Constant, I guess. Okay. Yeah, I think that's what I'll do. Kind of want to do that. We got to handle the initial move into A0. So, I think actually this is gonna work just fine. Yeah, I think this will work just fine. I don't think we need to use start at L here. Probably just use A2I. Probably. And then so we want to get the next token after we see an add. The next token should be a integer, so we can actually check that. That kind of gets into error handling, which might be better to do next time. Yeah, because we're starting to get into building a parser here, so it'll be better to pull that out for next time, I think. So I'm not going to worry about handling that this might be the wrong token at this moment. Okay, I think this code should be equivalent, and we still need to print the error. Mostly equivalent. I was putting it into A1 rather than using the immediate, but I think this should also work. Yeah, that should work just fine. It should. Let's try it. Oh, everything passes. That's a good sign. Why is it? Oh, probably ought to handle those. I'm just gonna crash there. Maybe. So I'm actually surprised that this works. I thought I had a bug. Move A00, okay. 521. Oh, this is not running the new code. Oop. Ah, there we go. Add missing switch cases, yes. I'm just gonna do while true here and move this into here, then remove this and case ERF. I'm just going to print this and return. DK invalid. I'm gonna return print printf standard error. Like that. like that and see? Seems like you can. Good. White space is not being handled, but it should already be handled. So, okay. Making gauzy. All right. Now, this should fail. No? 0, 42, 5, add 20, sub 4. Okay. I was expecting the invalid token that it gets initialized with to have a problem with the finding the token end here, but I guess not. No, I guess because this will be invalid, so it'll never get to here. So I guess I actually inadvertently handled the bug that I was expecting. Okay, cool. So I think this is working, and it should now handle white space. So let's go into our tests and add some more tests here. That should work now too. Let's try that. And it does. Excellent. So we now handle white space, and we've got a proper tokenizer working. So I think this is a pretty good place to call it quits. Thank you very much for watching. I hope if you feel inclined to express gratitude that you can figure out how to do that. I won't tell you what to do. And yeah, I hope you have a great day. Bye.